5. 5 times 5 is?
25.
Yeah. Hey folks, welcome, and welcome. It's Mathline time. Yes, it is, but don't call in. Not a call-in day. This is specialized segments time. But you know what? I'm still Ernie Roberts. I'm still your host, and we're going to have some fun doing some math today, all right? Get your calculators out. Oh, my goodness, yes. And thinking caps on. You know what those things are? We used to call them thinking caps. They put on, it really would make you get brainiac or whatever. Well, we got some good stuff today. We are, once again, a specialized segment, so we zero in on a topic, and we work at it, we practice at it, and hopefully become pretty proficient at it, all right? And how about it? What's the topic about today, guys? Let's take a look at it and see what we've got. It says scientific notation. What a surprise. You know, we've been doing scientific notation quite a good bit of time here. The Great Divide, which simply means, you know, that's why we're going to do some division here. So looking at scientific notation, the Great Divide, let's take a look at some problems. Why not? Got a couple to start us off with here. And it's division, so we're looking for a quotient. There we go. There's the magic word. It starts with Q. You can spell it out. Q-U-O-T-I-E-N-T. Leave your answer in scientific notation. Oh my goodness, we're just going to keep blowing that thing crazy, aren't we? But you know what? This is a good old ACT review moment, and also a good old Algebra 1 and sometimes Algebra 2 review moment here. So let's take a look at how we're going to work with division. First of all, you know me, I like to just take the tens and let's go back to the basic exponential rules. Because we've already played this game with bases of variables and stuff and various sundry things. And notice we have the same base of 10 here. So what I'm going to do, I'm going to let the letter A represent 10 in both of these. And let's just say we solve this. Now again, go along with me here. We'll get rid of that little x, the times sign there. By the way, that's what that's about. It's not the variable x. And we're going to say we got a to the 13th. It's real straightforward, isn't it? And here we go. Let's put 1 and 3/10 right there. And we've got, you got it. Replace the 10 with an a. And we're going to have a to the 8th power. Now, what's the game plan here? You say, well, Ernie, what is the game plan? The game plan here is to remember, what do we do when we have a division situation? Now, we have worked through cubing and squaring scientific notation experiences. We've also worked through multiplication, but this is the first time we've really tapped into the division. Remember, division is the exact opposite of multiplication. So what did we do with the exponents when we were multiplying? We added them if they had the same base. Well, this has the same base. If we were in a division moment, we're going to do what? Everybody got it? You said it. I said it. We'll all say it. Subtract them. So divide the coefficients. Oh, goodness sakes, do not divide. Do not divide 13 and 8. You won't have anything pretty, that's for sure. That's what we subtract. Here you do the division, and it may not be pretty, but let's check it out. Calculator time, let's see what happens there. I've got 5 and 2/10. And you all are already on your calculators over, right? You got it. Nod your heads with me. Thank you, folks. Very good. This one I'm thinking is going to come out even. It's supposed to come out even. Sometimes, yeah, there it is. So we end up with 4. All right, so let's go back to the original page since we got the hard part done now. We've got 4 right there. And remember what we said? We keep the base and we subtract the exponents. 13 minus 8, la-di-da, you get 5. So are we done, Ernie? We're done. Now, like I said, let's box that in for a little bit. Can you see how we're going to work this one? How are we going to do this? That was basically if 10 were an A, or A was 10, however you want to look at that. All right, we basically did a little replacement job here and went back to our old rules. The rules are still the same. We're still going to do what? We're going to take 5 and 2/10 divided by 1 and, got it, 3/10, which is going to give us 4. We'll put that little pesky X there because it's scientific notation. We always put that there. That's the time symbol. And then we got what? The base is 10. And we're subtracting those exponents. What's going to be the 10? 10 to the 5, right? 10 to the 5 power, 10 to the 5th power. Are we done? There's always that question. Are we done? Well, 4 is between 1 and 10. Looks pretty good to me. And we got a power of 10 there. So we're good. We're in scientific notation. Remember that number that's out there in front cannot have 2 digits to the left of the decimal places, nor 0 digits to the left of the decimal. You said, well, there's no 0 digits there. No, but there might be. We'll see that happen perhaps in just a little bit. So just keep your eye on it. You say, then we have to make an adjustment. Exactly. So let's go to our second problem here. Let's not worry about going with A's and X's and all that kind of stuff, but let us do this. I definitely do not want to try to calculate that little fraction. Let me clear out what we got here. Let's go back to the calculator and let's pick up what 3 68/100ths. And we're going to divide that by 2 4/10. Now, by the way, folks, when we do the scientific notation, I have a feeling this thing is, yes, it's going to ramble on. Let's just put it at hundredths place on this. There's no real rationale why I just told you to do that, except it's a repeating 3, as you notice that there. And we can put the repeating 3 on there, but notice it's in the scientific notation format there. See that 1 5/10 or 5/5300ths or 533 thousandths. We could go on and on ad nauseum, and you'll turn the channel, okay? But we don't want you to do that. So let's go on to our page here. We're going to put in that little old 1. We're just going to let it go at round off to the nearest hundredth, okay? Your calculator will do stuff like that too as you go along too. They'll quit knocking all those decimals down there when you have to put them in scientific notation in a lot of cases. Now, as I ramble onward and you all are ready to go upward, right? What do we do? What do we do with these exponents? We have, off to the side here, a -4 minus that -5. Now remember the game plan here. We're subtracting exponents. That is not saying -4 minus 5. Absolutely not. We've got to do the -4 minus that -5. So be careful. Watch your signs because they're going to change right here and there. That's going to become -4 plus 5, which is going to give us 10 to what power? 10 to the first power. And you're saying, Ernie, that looks like it's finished. Boy, that was quick, wasn't it? All you had to worry about, of course, those exponents, and you let your calculator do that 1.53 or that 1 53/100th moment for you there. And again, it's your call on how many decimal places you want to put out there with it. I left it at just 2 decimal places on that. And usually it's the call of whatever your instructions on your document or on your test or on your problem, whatever they say in the instructions. So follow that. So I'm going to be in the instructions for that one. It's going to be 2 decimal places. How about it? So there we go. We get the idea of the quotient. It's not difficult. We've played the rules with quotients before, all right? So what we're going to do is we're going to look a little practice time here. So let's go on to our next lesson part here. Thank you, guys. And let's take a couple more problems out here. I have 6 5/10 times, this time, 10 to the 5th. And again, oh, by the way, you always want to read our instructions, right? Simplify quotients. You figure that's probably going on. But that's what it says. And again, we're looking for scientific notation. Now, yes, folks, you could leave standard notation, but it asks for what? Scientific. So we'll go with that result here. So again, we're starting off with coefficients, in this case, 6.5 or 6.5 or 6 5/10, however you want to look at it. We got 5. I put a 0.0 there just to have fun with it, but it basically is 5, all right, times 10 to the 10th power. We're going to play the game. All right, we're going to divide these guys together, and we're going to do the subtraction of the exponents over here. So let's take a look at what happens. Let me clear off what we had originally there. We had that last one going. All right, let's go back to our calculator. We're going to go back and forth a lot today. Just kind of give them a heads up upstairs there. I've got 6 5/10, and we're going to divide that. And by the way, it is important which order you put those in. It's something over something. You put the something on top in the numerator first, then you divide by what's in the denominator, and you put the right digit there, right? Everybody's going, hey, that's supposed to be a 5. I know. There we go. And we'll enter, and it looks like it's going to be something like 1 3/10. Didn't round it off. That's exactly what it equals. So let's take a look at where that one came out in the plan here. That's going to give us 1 3/10. And what do we do with our exponents? This time, we're still subtracting, aren't we? Everybody's saying, no, yeah. So we got 5 minus the 10. 5 minus 10. Aha, negative. That time, notice it wasn't like negative 10 there, and we know we have just a positive 10. So we're saying 5 minus that 10, and that gives us a negative 5. Remember, it's like saying adding a negative, so there's your exponent. Yes, you could do that mentally, couldn't you? That's what I want you to notice. As we work through some of these things, you start getting back to the rules and the thoughts of it. Most of this calculator gets that part. This part can be done up here, mental math. Sometimes it takes a little bit of stepping to do, but there we go. Now, what did I say again? That's the exponent. Keep the base the same. Put the little multiplication moment right there. Keep the base of 10 the same. And what do? We subtract those exponents, which is exactly what that was about. And it looks like there we have it. Always the question, is it in scientific notation? Well, this one happens to be so, doesn't it? 1 3/10 times 10 to the negative 5. The 1 3/10 obviously is between 1 and 10. And definitely has only one digit to the left of the decimal. That's what we want. Now, one more quick look at this one up here. This one looks like it's back to making us think a little bit. You all practice it at home. Write it down. There's 6 2/10 times 10 to the negative 6. 3 1/10 underneath that times 10 to the negative 8. I think I gave you some nice numbers to come out even. We're not going to always be nice, am I? You know that. No, but with calculator, it's not a difficult task. But let's do it. Let's see what happens there. I think that's going to come out even, but just for all of you who love to make sure that I'm on my rocks and know what I'm doing, let's take that 6 2/10 and let's divide it by 3 1/10 and see what we get. I'm hoping for 2. We got 2. And what do we do with our exponents? Again, remember that negative 6 subtracting that negative 8. Okay, it's like, again, it's adding the opposite. The signs are going to change for us. And I am seeing times what? It's 10, right? Yeah, I've got to keep the 10. But what happened here? That gives us, this time, a positive 2, because the positive is going to win out over the negative. So we're going to raise it to the second power, and life is good. You say, wow, that is not really very difficult, is it? And by the way, it is in scientific notation because I only have one digit to the left of my decimal point. All right, everybody good? Oh, you said there's no decimal point? Yeah, there is. Remember, it's after the 2. It's after 2 on this one. So that's our story. Pretty easy, pretty straightforward. I'm wanting to be that way, all right? So let's move forward and let's check out our next little creature here. This one says, simplify each quotient again. Oh, there's quotients, yeah. We're going to leave the answers in scientific notation. Okay, so the rules are pretty easy, right? We take these coefficients, we take 4 6/10, we take this 9 2/10, we're going to divide it. And you know us, you know all of us, we love that calculator, so let's go back to it here. So we got 4 6/10. We will do a division moment here, 9 2/10. And oh my goodness, we get 5/10. We get a half. That makes sense, doesn't it? You look back at that number, that looks like that. So here's the story. We'll put it there as a decimal because that's what the calculator gave us. And well, it's also what we think of when we're looking for scientific notation. We're talking about our decimals, right? The good old rule says we're going to take those 10s, that's our base, and we're going to subtract the exponents. So this one's, oh gosh, 4 minus 2. You never thought you'd be asked that on Mathline, were you? But there we go. It is going to give us 2. And everybody says, oh, are we done? And all of you who have been watching the scientific notation series or have been a part of it or you've had it in class, you're going, no! Because we don't have a number to the left of the decimal point. That's a problem. So what we're going to do, we've got to move it backwards. We've got to move it back and get a 5 here. Now, folks, what did that mean? That meant I multiplied by a power of 10. I multiplied one decimal place over. I multiplied by 10. So if I multiply this little guy by 10, I've got to divide this one by 10 to keep it equal. You say, Ernie, can you come again on that? Yeah. We're multiplying by 10 to go to this 5. So I've got to balance it out. So over here, I've got to divide. So I basically do not change the value of this expression we have. And that's going to give me a subtract situation because it's getting smaller, right? We're going to divide by 10. So we're going to drop the power by 1. You say, oh my goodness is right. Now, those of you who are wondering, and I know you are, is it really the same? Let's go to the calculator and let it tell us. Let's put in 5/10, and we're going to multiply it by what? 10 to the second power. Well, just for those of you who are going like, do you think it'll work? Let's put it in there. We'll put it in there to that. That's not where it's supposed to go. Let's try that again. Delete that moment. I got a little excited. I'm supposed to put my 2 in there. Okay, and let's see if it'll just go ahead and give us an answer here. It doesn't like me. Okay, let's try that one again. We'll go again. Let's just clear that whole thing out. How about it? 5/10. I love it when I go into a technology moment and they don't just quite work. So we'll raise 10. We're going to go to the x squared. That's all we got to do. I don't know why I made it so difficult for you all. Sorry about that, folks. And we get 50. All right. Now, the other, that's by the way standard form. Well, what's going to happen if I say 5 times 10? That one's pretty easy. We get 50 again, don't we? So comparatively speaking, both of these give us 50, but remember, scientific notation by definition, that's what we want to come up with is the 5 times 10, and we'll put a 1 on there because we're using the powers of 10, okay? And that's how that one works. Let's take a look at our next little creature here. Some of you have already probably gone way ahead of me on that. I hope you have. Let's take a look at this one. Now, I'm going to go ahead and tell you, 3 divided by 8 is going to give us a crazy decimal, but at least it comes out even. But it's 375 thousandths. Okay, that's what 3 divided by 8. If you don't believe it, try it on the calculator. We'll check it out in a minute anyway. Now, what are we going to do with these guys here? I've got 10 to the negative 3, and then I've got 10 squared. I'm going to take negative 3, and I'm going to subtract 2, which is going to take me into the depths of all messes here, right? I have a negative 5. Now, this time we do have the subtract 2 moment. All right, everybody see the difference? Because we didn't have a negative 2 subtract a negative 2 here. We just got subtract 2. All right, now, with what's got going on here, again, I need to maneuver that decimal. So I'm going to slide it over one place this way, which means I multiplied, remember, by 10. So we're going to put 3 7/75 right there. What's going to happen to this little guy? Since I made this larger, this one's got to get smaller. Now let's think a minute. That means we're going to take another away from negative 5. So we're going to have negative 5 minus 1, which is going to bring us down to the negative 6 power. Remember this, it's the opposite of what happened when we were multiplying. Remember, we were bringing it down to offset the balance yesterday, or another, if you've seen the other videos, there was multiplication. This one, we have to raise it up to offset, no, we got to raise this up to get to the scientific notation, so this one goes down. So it's like I said, one goes up, one goes down. It's a nice balance of power when you look at the scientific notation effect on the exponents if you need to maneuver it. Here we had to maneuver it, here we had to maneuver it. On the other ones that we had just a few minutes ago, if you were watching the beginning, they were all ready to go. We were just hunky-dory and happy that we knew how to subtract exponents. But here you got to watch your exponents one more time. Now, that gives us a good idea. Let's practice a couple here. In fact, let's make it a little more fun. How about it? You're probably going, oh, yeah, let's have fun here on Mathline. Why not? Let's see what we're going to do here. I've got, simplify this. Write this one down, folks. 3 5/10 times 10 to the 8th, boom. 2 6/10 times 10 to the 5th, boom. They're all in the numerator, and there's not a division sign. That's all multiplication, isn't it? Woohoo. And on top of that, we're going to divide by something here eventually. So let's go to that calculator immediately here. Hold on, let me get rid of those last things because those are pretty easy. Now we got to think. We got to think on this one, dear friends. So let's take that 3 5/10 and multiply times 2 6/10. And I'm going to do this a step-by-step process. That gives me 9 1/10. I'm going to leave that as part of my problem right here, okay? And now, notice these exponents here. What do? It's a multiplication situation. Forget about 9.8 and 9/8 and all that good stuff. Forget about your denominator here. Let's just play with the numerator a minute. We're going to add those, right? Keep the 10s together. Keep the 10 as it is. We're going to add the 8 and the 5, and it's going to give us 13. All right, so life is good. Sort of now looks like the problem we were just doing, right? Underneath, we have 9 8/10. And we're ready to multiply that thing by what? 10 to the what power? The negative 2. Watch and notice here. I hope everybody's already going, oh, the 10s are easy. This one, easy. Let the calculator do the work for you. Let's go back there. And we're going to put in 9 1/10. We'll divide it by 9 8/10. And I already tell you something here. This is going to be less than 1. And that's why we want to be careful. And that's going to give us, I want to round this off. I want to round this off somewhere. How about it? Let's see. We got, 9 2. Let's just go to the 3 decimal places, all right? it was roughly rambling on and on. It was really kind of hard to decide where to cut this thing off. So we'll go right there, times, and what do we do with those? Remember what we do with those exponents? 13 minus the negative 2, mental math time, gives you 10 to the 15th. Folks, that's a big number. That's really a pretty big number there. We're going to reduce it down by 1, but it's still, that's a large exponent. We're talking about powers of 10. All right, let's move this thing over because we really want scientific notation. So there we go, 9 and, wow, 29 hundredths. And remember, since this went up, we've got to balance back down on the other side. We multiplied here, so we're going to divide by 10, which means we're going to knock the power down by 1. And that's going to give me 10 to the, what is it? You got it out there? Of course you do, 14th, right? So there's our final story on that one. And I hope y'all got that right. And again, 3 decimal places was fine. That thing rambled on and on forever, ever. That happens sometimes. So do the best we can with it, right? Now, think we can do one more? I think we get one more, maybe even 2 more. Let's see, we've got 5 minutes left, they tell me. So let's play one more out here, all right, and see if we can't get maybe even to 2 more. This one's getting a little crazier. Let's see. I'm already, you know where I'm also going to go. I'm already looking at these numbers that we got to multiply. Let's do the numerators first, okay? Don't worry about the denominator. Do one thing at a time. I know a lot of times my students look at problems like this and they get overwhelmed because they see so many things. Just decide to do something, okay? You don't need to do all 3 things at one time, all right? Let's just take care of the first 2 that are in the numerator. We know how to work those. Multiply, so let's go there. 9 4/10. And we're going to multiply that by the other coefficient, which is 5 3/10, believe. And I hope I pressed the right buttons on this. I think we did. Yay. All right. So at this point, I'm going to go ahead and write that down. 49, what is that? 82 hundredths. Whoa. And we've got what? 10 to the, oh, got to add those exponents. Don't try to subtract. That's not a subtract time, my friends. It's going to be 10 to the 2nd, right? We got a negative 4 plus 6, mental math time, all right? Underneath that, we have 2 3/10. And we got, oh, that one's easy, isn't it? We got times 10 to the what power here? To the 5th. And I guess it's time to play coefficients, right? I know what we're going to do here, right? We're going to subtract those exponents, and it's going to be fun. Is it going to be fun? It's going to be fun because you get the right answers, yes. So let's see here. 49 82 hundredths. Woohoo! And we're going to divide that by some crazy 2.3 or 2 3/10, which probably is going to give us some crazy fraction. I just have this feeling. And I'm right. So a crazy decimal there. So let's just go to 2 decimal places on that. Actually, let's go to 3. We'll bump that 0 to a 1. So how about it? We'll say equals 21 and 661 thousandths. We'll just bump that up. Again, it's kind of one of those things. Times what 10 power here, my friends? 10 to the what? The negative 3. 10 to the negative 3. Now, you say, Ernie, there's 2 digits to the left. That means it's too big. So what do we got to do? We've got to bring this 21 back down. We've got to divide by a power of 10. So here we go. 2, there's your decimal right there, and move it, just simply move it one place. But what that means is you divided by 10 here. Remember, to offset by dividing by 10, we've got to do what? We've got to multiply by 10, which means that's going to go, you got it, I'm going to bump up this time. So how do we bump up if we're at negative 3? We bump up by 1 by adding negative 3 plus 1, and we get what? 10 to the negative 2 power. And there is your final scientific notation. So it's kind of going back and throwing a few different things with us together, all right? They say we got 2 minutes. I'm going to show you one. I'm going to leave you some homework. How's that? At least maybe get you started. Let's take a look at one last problem. You can at least copy this down and we'll see what happens. And what I may do is put this out there on a Mathline show or just may attach it to our, as an addendum to this problem somewhere, okay? Oh my goodness, we got all sorts of things. What did I do this to you for? I put a 2 there, which means we're going to square. So let's take a look at this thing. We aren't going to be able to do this in an hour and 30 yeah, we could. A minute and 30 seconds. We're not going to be able to do it. But let's just take this and take this home and see what happens. 2 3/10 times 10 to the 6. There's a quantity. 1 36 hundredths times 10 to the negative 3. And we're going to square that. Now remember, what does that mean with the exponent? you're going to multiply that to make that a -6. A little hint back to you. You're going to have to square 1 and 36/100ths, all right? So square that number times itself, all right? And work that part out first. Now down here, you're going to do also the same old thing. You've got 7 and 8/10 times 10 to the -4. And you're going to do the same thing here with the 9 and 75/100ths times 10 to the -4. You're going to multiply those together, and then you're going to play the final game. Oh my goodness. I think that's worth a look at another show, all right? So, but anyway, there you go. You'll have to look on Mathline. Where's it going to come up? I may even just put it in a note on the Facebook page one day here, okay? Anyway, a little homework for you guys to do there. That's kind of tricky, but it's very doable. And you and your calculator will have a great time doing that. Hope you've enjoyed the show today. The Great Divide. That's what we've been doing, learning what to do with division, but also while we still review those rules for powers and also multiplication. They all connect together. They're all very well related. And once you learn them for exponents, this stuff is easy, right? Hey, thanks for tuning in. We will be back again live next week for more fun.